Hello everyone, in this video we cover SLR1 parser. So let's we start. So first we see all the rules which we follow when we do any action or perform anything in SLR1 parser. So let's start. So the first rule is augment the grammar. Augment the grammar and number it. Second, find first and follow. Find first and follow. Third one is construct the DFA. Construct DFA. Fourth one is parsing table. Draw parsing table. Fifth one is stack implementation. Stack implementation. And last step is parsing tree. Parser tree. So let's we quickly start to solve the parser. So for that let's we consider the grammar is yes read cAd and a read ab or e. So this is the grammar. So the first step is augmented the grammar and number it. So how we do this first step? So the starting symbol is yes. So we consider first yes dash. So yes dash read yes. So first yes dash read yes. So the number is 0. Then yes. So yes read cAd. One number. Then a read. Now here two grammar is read. AB separate and small e separate. So first AB and a read e. This is separate. So 2 and 3. So first step is completed. Now second step is find the first and follow. So let's quickly find out the first and follow. So the first of yes dash. So first of yes dash. So the first yes dash read capital yes means non-terminal. Then capital yes read small c. So the first is C. You always write terminal. So the yes dash is small c. First of yes dash. I hope you know the rules for the first and follow, and if not then please check my first and follow video where I explain in detail. Now first of yes. So first of yes is small c. The starting of the grammar from C. So this is the first of C. First of the yes dash is starting symbol of grammar is capital yes. And we want terminal means small letter or operator. So that's why we again visit that grammar, and from this we put it small letter or the operator, or we say that terminal. Now first of A. So first of A is small a and small e. Two are present. So in here also the first of A for this grammar is A and first of E is second grammar is E. So first of A is small a and small e. Now follow. So follow of yes dash. So C in grammar where yes dash is present at the right side. So yes dash is not present. So and it is the starting symbol of our the newly generated grammar. So always we write dollar at the starting symbol of the grammar. So the dollar. Now fall of yes. So fall of yes. Now again check at the right side where yes is present. So here is the yes is present at the right side. So from this, now this capital yes is followed by null. So we find out the fall of yes dash, and fall of yes dash is dollar. So we write dollar. Now fall of a. So fall of a. See at the right side where the a is present. So here a is present. So now this a is followed by small d, and this is the terminal. So we directly write here small d. So in this way we find out the first and follow. So this is the step number 2. Now step number 3 is draw the construct the DFA. So let's start for drawing the DFA. So let's draw the DFA. So we start from the first symbol yes dash. So yes dash read dot yes. All the grammar we write as it is, only dot sign we write in front of each grammar. Now dot yes. So dot yes is the non-terminal. So that's why we write all the grammar of yes. So now yes read c dot cad. Now dot c. So c is the terminal, small letter, not capital letter. So now further we not write anything, because if the capital letter is present, only that way case we write the grammar in below of the condition, and if not then we stop here. So this is our first state, I0 state. Now we visit one by one all the grammar. So first we visit here yes dash. So yes dash change. Now we change this dot operator. So this dot operator is changes with respect to capital yes. So we write here this dot operator now changes with respect to yes. So now yes dash read yes dot, and now we not write anything in further below of the grammar, because this is the last case, acceptance state. When the dot operator is the end of the grammar, that time we reach to the final state. So this is the completed. Now second yes read dot cad. Now we move this dot with respect to c. So c with respect to c, and now this yes read c dot ad. Now after dot one non-terminal is present. So we write all the grammar of non-terminal. So a. Now a produce two cases. A read dot ab and a produce dot e. Produce dot e. Now this is the non-terminal. This is also terminal. So we not further explore anything. So this is I1 state. This is I2 state. Now I0 state is completed. Now I1. So it is also final state. So we not do anything. Now I2 state. We visit one by one all the grammar. So first here yes read c dot ad. Now this dot is changes with respect to a. So we write here yes read ca dot d. Now dot d. So d is the terminal. So we not further explore this d. So this is the final state for the yes. So this is the I3 state. Now second one a read dot ab. Now with this a dot is changes with respect, this is with respect to a, and now this is small a. So this dot is changes with respect to small a. So a read a dot b, and this is our I4th state. And now next this e. So this dot it changes with respect to small e. A read e dot. Completed. So we complete I2 state also. Now I3 state again. So I3 state. Now this it changes with respect to d, and this term is not present earlier anywhere. So we explore more. So this changes with respect to D, and this yes read CAD dot. Now this is the final state because we reached to the dot at the end of the grammar. So this is completed I3. This is I4 state, I5 state, and I6 state. Now this. So A changes with respect to B now because here we not reached the end of the grammar. So B, now A read AB dot. So this is the final state. So this is, let's suppose, I6 and I7 state, and we are completed I3, I4, now I5. So it is itself complete final state. Now I6 also final state and I7 also final state. So here we get total 7 state, and this is the final DFA. Now next step is parsing table. So let's we draw the parsing table. So I hope you know, because this SLR is same like LR0 parser. Only the condition is changes is we find out in first and follow in SLR 1 parser, and LR parser will not do this. So I show you what are the changes here in parsing table. So parsing table, 4th number. Now how we draw this parsing table? So vertically we write all the state. So here in DFA we draw total 7 state. So let's we draw here I1, I2, I3, sorry, from 0. So 0, 1, 2, 3, I4, I5, I6, I7. Now horizontally what we write, all terminals and non-terminals. First, terminals. So which terminals are present in our grammar? Terminals means small letter or the operator. So C, D, A, B and E are the terminals. So first we write all the terminals. So C, D, A, B, E, and one more addition we draw right here, $sign. This is essential in parsing table. And now all the non-terminals. So non-terminals are capital S and capital A. S dash we not consider here. So capital S, capital A. Now let's withdraw. So first I0 in C. So in I0 this C is transfer in I2 state, and this is transfer, we shift this C in I2 state. So we write here S2, not I2, we write S2, S2. Now I0 and D. So in I0 D is not transfer anywhere. Now I0 and A. I0 and A is also not go anywhere. I0 and D. So I0 not transfer D anywhere. I0 A not transfer, only I0 transfer C and S. So S is transfer in I1 state. So this is the non-terminal. So for that we write only 1, not S1 or I1, only 1 in S. So I0 and S is 1, and for this C we write already S2 because C is transfer into I2 state, and remaining we put it blank as it is. Now I1 state. So I1 state is the final state of the starting symbol. So we write in dollar acceptance state. So I1 in dollar acceptance state, because this is the final state of the starting symbol. Now I2 in C. So I2 not transfer C anywhere. it transfer A, E and capital A, small a and E. So first capital A. So capital A transfer in I3 state and it is non-terminal. So we write 3 in below of the A. So I2 and A is 3 because this is the non-terminal capital letter, and this is the small a is the terminal, and this transfer in I4 state. So we'll write S4. So I2 and A is S4. Now small e. So I2 transfer E in I5. So we write S5. I2 and E S5. And remaining we not do anything, stay as it is. Now I3 state. I3 state transfer D in I6 state. So it is only transfer D in I6 state and it shift this D into I6. So we write S6. So I3 and D. I3 and D here S6. Now I4. So I4 transfer B only in I7. So I4 and B is S7 because this B is transfer in I7 and this is transfer means shift. So we write S7. So we write S7. Now I5. So I5. Now this I5 not transfer or shift any symbol in any state. It is acceptance state. But this acceptance state is not for the starting symbol. It is random any state. So now this is the acceptance state means we reduce the grammar, and this grammar is present at the third number in the initial grammar. So we reduce this third number grammar means R3. But in LR we write R3 in all the terminals, but here in SLR we see the follow of this. So this is the starting of A. So we see now follow of A. So the follow of A is D. So we only write R3 in column of D. So in column of D and I5 we write R3. Not in LR we write R3 in each terminal, but here only below of D we write R3. Why? Because this is the follow of A. And why we consider A only? Because this grammar is read for A. So this is the final state. For the final state we reduce the grammar. Then how we reduce? Only for the follow of A, and follow of A is D. So we write reduce D and the grammar number is 3. So R3 we write in below of D. So only these changes we do in SLR. R3 and remaining as it is. Now next I5 only we write for D only. Now I6. So I6 this is also final state. So now this is the final state means we write reduce. For what reduce? We see now follow of yes. So follow of yes we find out here dollar. Follow of yes is dollar. So we write reduce in column of dollar, but this grammar is where present yes read CAD. Yes read CAD is the first number grammar. So we write R1 in below of the dollar. So R1 in below of the dollar. R1. Now I7. So I7 is here. So this is also final state means we reduce the grammar. So follow, now here grammar is read for A. So we see the follow of A. So follow of A is dollar, and which number grammar it is? A read AB. So A read AB is 2 number grammar. So we reduce means R2. We write in below of the D. So So in below of D is R2. So this is the way how we draw the parsing table in SLR1 parser. If you not get the idea about this, then let me know in the comment box. I try to solve your confusion. Now we move for the next step, is stack implementation. So let's start. Now stack implementation. So for that we draw the table stack, input and action. So at the top of the stack, for the empty stack is dollar is present, so right here dollar. For the input we assume cAd. This is the input string, and after input string we write $1. And action, so we start from 0th state. Our grammar is start from 0th state. So now we check one by one. So 0 means I0, and always in LR0 parser or SLR1 parser, the stack is at the top of the stack number is present. So now 0 means I0 in C. So I0 in C is S2, means S2 means shift 2. So we perform here action shift C as S2. So now $0, now C, this C shift here, and the number is 2. Now this ED dollar as it is, because we shift C here. Now 2 and E means I2 and E. So I2 and E is S5, means shift S5. So shift E S5. So we shift E. Now $0 C2 E and this 5. Now D dollar. Now this 5 and D. I5 in D. I5 and D is R3, means reduce R3. So 3 means we check the grammar of third number. So third number grammar is A reduce E. So here we perform reduce A read small e. Now we reduce one variable, and if you check my LR0 parser, then I clearly mention how we reduce the grammar. So for the one variable we reduce one variable and one number of the top of the stack. So for one e we reduce this e and 5, means one variable one number. And if we say in number of character, then for 1 we multiply with 2, then we reduce 2 character. If here 2 variable are present, then 2 into 2 4, then we reduce 4 character. If here 3 variable are present, then 3 into 2 6, so we reduce from 6 character, means 3 variable 3 number. So it depends on you how we remember your trick. So I remember how many variables are present here, multiply by 2, and that character means 1 and 2, reduce this. 1 into 2 2, so 1 2 reduce. Now next, once we reduce this, write remaining all is as it is, $0C2, and what we reduce A. For this whole character we reduce capital A, and we want on the stack one number. So from where we get this number, we check the previous variable number 2. So I2A, I2 check in capital A. So I2 check capital A is 3. So write this number 3 here, and this D dollar as it is. Now this 3 means I3 D. I3 and D is S6, means shifter. Shift S6. Shifter for what? D. D with S 6. Yes, 6. So shift this. So $0 C2A3, and we shift this D, and number is 6. So 6. Now this dollar as it is. Now I6 and $. 6 means I6 and $. So I6 and $. Is R1, means reduce R1. So one number grammar is yes read CAD, 3 character. So reduce yes read CAD. Now how you reduce? So here 3 variables are present. So 3 into 2, 6. So total 6 character we remove from. So 1, 2, 3, 4, 5, 6. We reduce, or 3 variable are present means 3 variable, 3 number. 1, 2, 3 variable, 1, 2, 3, 3 character. So total which character we remove from this for the 3 variable. Now remaining is $0, and this dollar as it is. Now this whole characters for what we reduce, for yes we reduce. So write this yes. Now on the top of the stack we want number. So see I0 and yes. So I0 and capital yes is 1. So write the number 1 here. 1. Now this I1 and $. So I1 and $. is acceptance. So we write here accept. So we write here accept the string. So in this way we implement the stack. Now last step is draw the parse tree. So parse tree. So for what? This input string. The input string is cAd. This is our input string. So how we draw the parse tree? We visit to the table. From this action we go bottom to up. So first we see all the non-terminals. So here is the non-terminal action. Then this is terminal. We not consider non-terminal. Terminal. So these two action we assume for our drawing the parse tree. So first yes read CAD, and now A read E, and get it CED. So this CED, what we want we get here. So we perform all the steps correctly. That's why this is we quickly draw the parse tree. So in this way the SLR1 parser is work. Now if any doubt or any query, then let me know in the comment box. Thank you.